So again, if you type in Grasshopper, this dialog box comes up. So what we have here is basically we have a canvas. These are my old sort of um, Grasshopper definitions, and they're called definitions per se because they define a certain set of commands that produce a certain output. So for those of you that are familiar with 3ds Max, it's not like the modifier tab because the modifier tab is very linear. Although this software is very linear, we could start to produce sort of nonlinear connections in the sense that we start to loop information through and get results that maybe typically might not happen at the end but happen somewhere, alter something in the middle. Although it typically works from left to right. So it's typically always developing from left to right. And we start plugging into this canvas. This is a canvas here. Different components. So what are components? Well, components, and what I want you guys to do, if you go to Grasshopper, under tutorials, there's some good sort of you can see some videos here, but there's also a good sort of publication for Grasshopper that is free that gives you a lot of the ins and outs. So I highly recommend you sort of downloading one of these. And this is one if you have it, and I guess you have to subscribe. I haven't downloaded one of these for a while. And I think it's a good place to sort of look at and sort of, if you say, John, do we have a textbook? We don't have a textbook, but we do have an online source, and guess what? It's free, and it's based and it's written like a textbook, in the sense that it has all the sort of ins and outs that we might reference at some point. Okay, and you can see, people using stuff. So, and this has actually been updated recently. So it goes through installation. It talks about the user interface. It talks about even saving stuff. How to add, in this case we're looking at adding specific things to Grasshopper, how to add a component, what a component does. So I think it's a good place to sort of, I wouldn't print this out, I would just have it here as a reference. But I think it's a good reference, okay, to have. So free textbook as a PDF. So what is the interface like? Again, the interface is based off of this idea of having these very specific components. And these components have inputs and outputs and a body. If we look here, we have, again, like file. We have a lot of this copy and paste, how to view stuff, display things, solutions, help. And then we have the tabs that go through different types of things, like parameters, math, so we're doing maybe mathematical equation stuff. Sets of information, so we might have sets of numbers, sets of geometries. Vectors, which are points and direction, we'll talk about vectors. Curves, surfaces, meshes, where things start to collide, intersections, transformations, scaling, rotating. Displaying, how we might show stuff in color or materiality. Firefly is something we're going to use, not in this class, but it would be a class you might use like at IIT at DC4, which I teach. Weaverbird is something we might use, which we might use later, depending on how we deal with T-splines. So we can keep on adding more plugins. So you guys don't have Firefly or Weaverbird, I assume. Yeah, I'm not sure. You have Firefly? Oh, great. Okay. So they listen to me on that So we have all these different things, and within here are different components. Again, I'm not a big button pusher. Um, I'm more of a command, in Rhino. So if we double click in the workbook, we can start typing stuff. Like I can start typing in line, and then I'll start getting all different types of lines. Now, again, in the beginning, these won't look very familiar, but I might want a specific line, like a point-to-point line. In this case, it's point A to point B. So I know this one here, this icon is line A to B. And here's the component. So we get this little component. So this little component is basically making a line associated directly into Rhino. And it's looking for specific things. It has an input, it has sort of what we call a body, and then an output. Its input is 2 points, A and B, because that's the minimum we need, and then the output is a line. So we can start inputting a line into Rhino if we have points. Well, where can we start to find points? Well, under vector we have points, so we can have like construct point. And this is constructing a point based on a position X, Y, and Z. Right? And I need 2 points, so I can control C, control V that. And now I can start putting in parameters and numeric parameters for point X, Y, and Z. So what I did is I grabbed what's called the number slider. And I'm going to change, if I right-click on number slider, I'm right-clicking on it, I can edit. And within that number slider, I can change the range. So let's set it to 100. So the range is 100. As I now start to slide the slider, you can see my point moving, right? So that's moving at about the X. If I get a couple other ones, I can move it about the Y, and then I can move it about the Z. We can't really see it in the Z unless we go to perspective. So that's that point. Okay? And I can do this the same. I can take all these, control C, control V. All I'm doing is going to the ends here and pulling, oops. If you ever make a mistake, put it in the wrong spot, don't worry, put the right one in. And now I have my second point. And then if I plug in the output, which is a point, into A, and the other one into B, we start to get a line. And now I can adjust that line. Now what's interesting is you say, well, that's not that exciting. Well, it starts to become exciting once we start doing really complex stuff, right? And if we start changing 1 or 2 parameters, we might start to produce a big variation or a big change. So the first exercise, the first thing we're going to do is start to test specific types of surfaces, which we're looking at as sort of Bezier and catenary. And the first exercise will just be looking at catenary. Now, why is this? We're trying to make potentially sort of these sort of shelled structures, and these structures are going to be based off of catenary curves. All right, and this exercise is just to get you guys sort of, number one, used to the interface in Rhino, used to the interface in Grasshopper, working within Grasshopper to produce maybe a certain type of geometry, and then going back into Rhino and then working with that geometry. So it's just sort of to create this workflow and then produce something that we can make. Like I said, I think early next week, I'm going to bring in some of the fun foam. or some of you guys are familiar with, and we're going to make some of these patterns. And then we're going to use the, and specifically, I'm going to ask you guys to bring in potentially scissors and needle and thread if possible. You can also glue this stuff together, but we'll talk about that later, okay? What we're going to be doing. And also using one of the other cutters, okay? Questions so far on, all right, so that's sort of the real quick sort of, so I can take these, I can delete them, and they're gone. So what I'm going to do now is I'm going to set up a couple things. Under vector, we can set up a grid, and I'm going to set up a square grid. So if I just type in grid, I think I type in square grid. I get square grid. This produces a grid. It's a little hard to see here, but there's a little grid right here. And again, this grid has certain type of parameters. If you ever want to know what they are, if you right click and you go to help, it'll tell you what all the inputs are and all the outputs are. So in here, the inputs are something very specific, and outputs are something very specific. Basically, what I want to make now is a jig, and the jig, and it's not, you know, like I joked, the jig is not a little dance. A jig is something you might use to sort of frame and produce like an output, right? If we think about a bike jig, this is what a jig for a bike looks like, right? You have a bunch of pipes, you cut them the right side, and you put them all together, and you can weld it. And you can make an adjustable jig, right? To make different bike frames, right? So we're going to be making basically an adjustable jig, not to make a bike, but to make these sort of curved surfaces, right? Does that make sense? So our jig is going to be something very simple, like think about like a building. What would be the jig maybe for a building? It would be probably a grid, right? Like a structural grid. All right, so this is what the grid can do. In this case, we have base point for grid, which is 0, 0. We have the size of the grid cell. Now, Rhino, 1 unit equals 1 unit. So units are decided not in Grasshopper, but they're decided whatever units are set up in Rhino. So if inches are set up, it's going to be an inch. So 1 is going to equal 1 inch. And again, we set this up to inches, and initially, so in this case, I'm going to set it up to feet. So we're working a little bit larger. So when I enter 1, it's going to be 1 foot. Because I want to make a slightly large dome, and maybe I don't care precision with inches. We can use decimal inches to say, 1'6". If you want to get really precise to inches, then we would leave it in inches, then we're using decimal inches. Everything is going to be in decimals, okay? So I can set if I go to parameters, I can come here and grab a number slider, or I can double click and type in number. So again, this is what you guys are going to do for next week, or come in with next week. And then if I right click, I'm going to say edit, and I can set my range, let's say 30 feet is the biggest I want to get for now. And then I'm going to set my grid size to 1 foot. So that's how big my grid size is going to be, 1. And then I can say how many do I want in the X and how many do I want in the Y. So in this case, if I right click, slider type, I can change this to integers. Integers are whole numbers, 1, 2, 3. Floating point are decimal point numbers, like 1.5 is a floating point. Odd numbers are 1, 3, 5, 7. Even are 2, 4, 6. Okay. So this is basic, maybe first grade math. You learned it, but I know everybody forgets. Some people are like, what is an integer? What is a floating point? So floating point is decimal. We want integers. So we're going to switch this to integers for both, because we're doing cells. We can't have 1.5 cells. So we're going to make 30 by 30 in this case. Okay. So here I have 30 by 30. Do you guys see that? So far, so good? Somewhat? And again, this exercise is number one to get you familiar both with Rhino and in Grasshopper. But then maybe see the power between the two. And then eventually we'll get into sort of the scripting aspect. Now that's how we would make sort of a grid that is, represented in this way. How will we do this manually? How would we maybe make some type of frame, like a grid like this that we want geometry? Yeah, or offset square. All that's doing it. The cell is a square, so we can replicate this manually. One thing to keep in mind is with Grasshopper, as soon as I close Grasshopper, the stuff is not there. The stuff is being sort of ghosted in to Rhino. I didn't lose anything. If you ever close it, if you open it again, it'll reappear, and it's there. Once we close Rhino all the way down, if we haven't saved our Grasshopper file, it's not going to save. All right. Now, again, because it's ghosted in, we're not really dealing with layers. It's just sort of all here within the components, and these components generate the preview. All right. Where in Rhino, we can deal with layers, right? So there's a layer here. If it's not shown up, we can type in layer and it'll pick it up. So if I take this and close this and type in layer, it'll appear, right? And layers work exactly like in AutoCAD, where if we pick a specific layer, in this case I made a layer called Ref Geo, which is like reference geometry, and I can change the color of it. And then I can start drawing. So what can I draw? I can do it old school way, like line 0, 0, and then draw 1, 0, right? There's the line. I can then offset it 1 foot, and then draw a line from endpoint to endpoint, just like in AutoCAD, and then join this, right? Or I can draw a rectangle. Rectangle, 0, 0, 1, 1. Did the same thing, and now I have two lines on top of each other. Okay? Just like AutoCAD. And then what would I do if I want to create this sort of... Great. What's my next command in AutoCAD? If I want to make a bunch of copies, array, right? So we'll do an array. How many in direction? Number, I want 30 and 30, just 1 and Z. And then what's my number spacing? 1 and 1. Right? I hit enter. And now I have the same setup. But now if I told you, give me not 30, give me 20, and X and Y, you'd have to redo it, right? Erase it, redo it. Where... let's just leave that on for now, and I'll turn it off. Where the power of Grasshopper is, ultimately, even more so than in scripting, is we have sort of the interaction where we can start to do that, right? And this can start to affect very specific things. And scale, right? Does that make sense? Okay. So it sort of produces, the parameter becomes interactive, and then the model becomes interactive. And this is, we can do these things in 3ds Max as well, right? We can make controls in 3ds Max. But let's look at the output. So the output are curves and then they're points. Now, the one issue of ultimately we might deal with is like start to understand what the output is. So we have this panel, or if we double click and type in panel, and we plug in panel, we start to see all the points. And we can see now we have a total of 30 points. And we see all the positions of the points. But we have more than 30. We have 30 set up And a specific type of organization, which we're not going to get into trees right now, what I'm going to do is just flatten this real quick. And we can see we really have right now 960. Now, why do we have 960? How many do we have in this direction? Not 30 by 30. What's 30 times 30? $900. Why are we getting 60? So we don't have really 31 by 30, but we have the 0 zeros, right? So we have one row of 0 zeros. If we went in this direction, it's 30 times, what's 30 times 31? 930, but we get another row of 30 here, right? Of the zeros and the x. Does that make sense? So we just want to verify, right? I don't trust people when they hand me back their money sometimes, right? So you count your money out, right? Not that they're trying to steal you, but maybe they're just being distracted by their cell phones. So we can see all the different positions of each point. Now, the other thing is to understand how this is maybe understood. How are points understood across here, right? How is this data being organized? So we can start doing that by extracting a certain point. So we can start to extract specific points from this list. This is like a list of information. So in this case, I can pull out a specific point out of that list. So that is called a list item. So this is a list of data. If I plug that into L, it's extracting a specific point out of here based on a index. These are all the indexes, okay? So each point here is numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can see this by, if we go to, let's go to point, and we go to point list, and I plug this in, we get all the numbers of all the points. And we can see it's going 0, 1, 2, 3, 4, 5, 6. So it's running this way. And we can change the size of that so we can see it a little better. And let's change this to 10 by 10. It's always sometimes better to start small. So we can see how it's counting it off, right? 0, 1, 2, 3, running this way. So if we wanted point number 60, and I'm adjusting the range on this. I have point number 60. It's a little hard to see right now, but it's right there. To make it visible, at point number 60, I always want to put maybe a sphere. So now as I toggle through the selection, it's going to grab that specific location. And in this case, my range stops at, let's put ahead and put 960. And once it goes too high, we start entering another problem. But we have to take care of what our list is in the sense of what's our actual count, right? So you understand that? Like how I'm extracting data out of that. Does this make sense so far? So far, so good? So the next thing I'm going to do now is I can just take all of this and copy it. So I'm going to take all of this. And now I have two different points that I can pick. And then these might be very specific. I'm going to kick this back up to 30 now. That might start to find a position on this sort of field. Okay? So that's like the two parameters right now, points on the sort of jig, right? So I'm using this as a jig. Again, I'm not doing this more other than just so to start to sort of think about, you know, how to interact with this software. And the next thing is I'm going to do is make, the sphere is something that's maybe just more visual that we'll keep for now. And then what I'm going to do is make a catenary. So a catenary is what I showed you earlier, which was the catenary. And then I'm going to plug in for the catenary A and B for the points. Okay. Now the one thing the catenary needs is length. Okay. Now a catenary can never be, the length of a catenary can never be shorter than the distance between 2 points. Unless it's a rubber band. Does everyone understand that? If you have 2 points, the distance between the 2 points can never be shorter than the line, right? So we can start using math. Hey, let's use some algorithmic modeling now. And what I'm going to do is use a distance command, D-I-S-T. And what this is going to do is measure the distance between my 2 points. So this is the distance between A and B, right? And I know the distance between A and B is 14 point blah. Whatever, point something. And now I want to know, I always want to have my catenary be 3 times as long as the distance between my 2 points. So I can start using some math and use a multiplier. So multiplication. Then I'll multiply my length times a very specific number. So I'll grab a number slider, copy it. Change, let me edit that so it's not so big. And set that to 3. I'm going to plug that in for my multiplier. And then my length is always going to be 3 times as long as the distance between the 2. Okay. Now you see how my computer's running a little slow? I can always come here and turn off this grid by right-clicking and turning preview off. And then, actually I'll leave the grid on. I'll turn these points off. These points, this also, my computer's running a little slow. Hopefully it's a little better now. So there's our catenary. The last thing on the catenary is G for geometry. No, it's G for gravity. So our gravity is right now negative 1. I'm going to switch that. I can set one vector and have it go up in the Z, unit Z, up 1. So all I did is right click and I said set 1. Or I can manage the collection and come in here and type in +1. So if I put in here -1, it's going to go back down. If I right click, manage, come here, 1, it's going to go positive. The reason why I wanted to go up, because we're going to try to make these sort of dome sculptures, right? Structures. Does this make sense so far, guys? So the great thing is now I can take this whole thing, maybe not all of it. Yeah, let's take all of it. And I'm going to make um, 3 different unique So I took the same definition and made a copy of all of them, and then I'm going to change the parameters. So I might take something here, and I know this is a little strange working on this jig, but because we don't really know what these points mean in the sense of position, but we could sort of scroll them. I think for some reason that sphere is really killing. I'm going to turn those spheres off because the spheres have a lot of geometry. So if I pick those and right click, I can say preview and that turns them off. Yeah, you have to pick each one individually, sorry. And again, this is based on the distance, so the larger the distance, the bigger the curve, yeah? So there is some type of logic behind that, right? And then the next thing is, I might want to start to generate a surface. So what I'm going to do is produce a loft. And a loft is basically making a curved surface based off of different curved geometries, which I'm ultimately going to use. Hold on, let me go ahead and free up some RAM. What I'm doing is plugging all these curves into lofts for C. And we have to make sure we get them somewhat in the right order. Otherwise it starts to make sort of surfaces that collapse on themselves, which maybe is not problematic. I think for this exercise it's not a bad thing. But this starts to produce a geometry then that we can alter and manipulate just based on numeric output. So let's go ahead. I want to go back. Well, let me just pause this real quick. All right, let's try this again. So we can see basically the way we enter the commands, still running really slow. I'm going to turn everything off except, so I can select everything and say solution, preview off, and it'll just have my final curve geometry. That seems to be helping. So if we start manipulating the position of these points, we start to make sort of different curve geometry, right? And the logic of sort of the jig maybe isn't great. And then we can start adjusting, like what does it mean if we increase the parameters there, right? And then maybe we actually want to bring this all a little bit lower. This is where we don't want this. Maybe we want a floating point, so we can get like 1.5. And then this surface here, we can do a lot of things with. So we have this sort of lofted surface that we can then start to look at sort of subdividing the surface. So the goal for this week is sort of to do exactly this on your own. Just sort of, it's more to just to get into the software and try to produce these sort of doubly curved surfaces. And then we want to output them and do something very specific to them. There's some commands. We can start doing certain things with the surface, like even on the transform. I'm trying to remember. Yeah, we still can't. We can start to offset the surface. Like if we start wanting to giving certain thicknesses to surfaces, we can, especially if we want to start to 3D print them. But sometimes it's easier to bake them into Rhino. So right now, this is not baked in per se, in the sense that we have not baked it as a virtual piece of geometry in Rhino. It's still just a preview within the software. So to do that, we actually have to go to the final output, which is loft, right click and say bake. Don't ask me why there's an egg. I don't know who bakes eggs, but. And then we can bake it to a specific layer and hit OK. So now this becomes an actual piece of surface in Rhino. So if I close this, there's my surface. And we can start to see a little bit closer maybe some of the issues we're running into, which maybe is problematic or not, but we start to get surfaces that start to intersect each other, right? And then, hold on, let me... So one thing we can do is rebuild the surface. And at least it should let us rebuild it. Yeah, I guess it's not letting me rebuild the loft. Let's go back to Grasshopper. As you can see here, we have options. So I'm going to get loft options. Oops. So loft options, you can see how the rebuild count, like how much we want to rebuild it so we get less geometry. So let's go ahead and grab a number slider. So this is dumbing down the geometry to fewer surfaces. So as I start to rebuild it, probably 10 is a good number. Let's try 10. Let's rebake it. Let's just throw it on default for now. So see how it's much simpler? So now, if I offset a lot faster. So you got to know these tricks, otherwise you're like twiddling your thumb for a while. So let's do that again. So let's offset it larger. Sorry, offset surf. Let's say 2 feet. There we go. So we can take this then and output it, right? Eventually what we're going to do next week is actually do these and then I'm going to show, the workshop will be pretty much like how to unfold it properly. So for us to unfold it, we can't unroll this geometry. Like if I try to unroll this geometry, it's not gonna work. It even says here, unrolling doubly curved surface will produce inaccurate. So we can do like other things like squash, which it won't even want to do that well. Look at that. So what we need to do is eventually is triangulate the surface, and then flatten it, and then recurve the edges that we want curved. And then when we print it as a flat piece, we can fold it back up to geometry. So this is a big problem with architecture if we try to do doubly curved surfaces, because it's great for like mice or like small things that are ejection mold that are small, but we can't like injection mold or vacuum form an entire 30-foot piece of architecture. We sort of can, but so that's why normally we need the subdivider, right? That's why if you look at Frank Gehry's stuff, it's panelized, right? So panelizing it. So we're going to do it without panelizing, but altering the geometry. Okay. All right, so I'll stop this right now. So this is the goal, to make one of these, and we'll look at how to output it for representation.